All right, guys, so need your review sheet out. Need your review sheet out. We're finishing going over it today, and we're going to start part 2 probably tomorrow because I do know that we have the Veterans Day, depending on when that is. Most likely, if it's not in the dead center or pretty much takes up the whole hour, we're going to do part 2 tomorrow, part 1. So, well, if it takes up most of the hour, then we'll just take the first part on Wednesday, do part 2 Thursday.
Will we be doing the test since tomorrow is Veterans Day? We just talked about
Yeah.
Oh, I didn't hear. I was looking for pencil. What did he say?
We're going to move it back a day.
Okay.
So, where we finished yesterday was completing the square. So we went through the process and the steps for completing the square on Friday. So we'll pick up here with the quadratic formula. Now, quadratic formula, first thing we're going to need to do with the quadratic formula is make sure the equation is equal to 0. We need to get the equation equal to 0. So we can look at either one. Y'all want to look at 26 or 27? 27. When we look at 27, the first thing we need to do is get this equation equal to 0. So we can add 4x squared to both sides. So we add 4x squared to both sides, we get this here. Now we don't necessarily have to add 4x squared to both sides. We could add the 7x and then subtract the 6, but I would rather just move one thing instead of moving 2, because the main goal is get it equal to 0. Now, quadratic formula, it does not matter, and it's not easier to do if a is positive or negative. It's going to work the exact same way every single time. Unlike factoring, it works a lot better if a is positive. And we have to make sure a is positive. With completing the square, we need the value of a to be 1. If it's not, we have to make it be 1, and especially positive 1. Quadratic formula, we just need to find the values of a, b, c. A is the number in front of x squared, b is the number in front of x, and c is the number without a variable. B and c can be 0, but for the most part, especially on the test, they're going to have a value. The only variable that cannot be 0 is a. We cannot have a as 0. Now our formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So we can go through and start plugging our values in. So negative b would be negative 7. So we have negative 7. Plus or minus, inside the radical, b squared would be negative 7 squared. Minus 4 times a. Well, our value of a is 4 times c, which is 6, all over 2 times a. So the first main thing I would do is just rewrite it with each number in its spot. We're replacing b, a, and c. A's 2 spots is being replaced with 4. C's 1 spot with 6, and B's 2 spots with negative 7. So we have negative 7 plus or minus. Yes, ma'am. The plus or minus? So then we have the square root of negative 7 squared minus 4 times 6. I would write it all out before you start simplifying, because if you feel comfortable, we can start simplifying. Even for myself, the only things I would simplify straight out, if we were going to do that, would be the negative 7, because our negative and negative make a positive. On bottom, 2 times 4 is 8. And really, if I was skipping the step above it, that's about as far as I would do. Inside the radical, I would still have our negative 7 squared minus 4 times 6. Mainly because we've already done 2 steps in 1. I would not push it any further than that. Because the more steps we try to do at once, the more likely a mistake or error is going to show up. Now at this point here, I would grab the 30XS, the yellow calculator, and type everything inside the radical just as it shows up to see what we get. I wouldn't type the square root because this here, since b squared minus 4ac, our negative 7 squared, minus 4 times 6 is negative 47. The 30xs will tell us that it's a domain error. The graphing calculator will give us an answer if we typed it in like this here, but it'll give us the decimal approximation. We do not want the decimal approximation. So we get to this here. Now we will have to simplify because that negative inside the radical, the square root of negative 47, that negative is going to come out as I. So that negative is going to come out as I. So that tells us for sure we're going to have to simplify this, at least taking the negative out. Now, as I said, the 30xs will not take the square root of negative 47. But we know that negative inside the radical is going to come out as I. So really what we're trying to see is, can we simplify the square root of 47? And it tells us, well, no. Square root of 47 is as simplified as it gets. And since the numbers on top, 7 and I, 1I, do not have any greatest common factors, especially with 8, we don't have a common factor in all 3 spots. This is as simplified as it gets. Even if it had been 2I, because 2I and 8 have a common factor of 2, but 7, 2, and 8 would not have a common factor, so that would be as simplified as it gets. But I do want you to take that negative out as I for sure. If you can get here, awesome. If you notice that it does simplify further, simplify it further. But I do want to make sure that you do not leave a negative inside the radical. We've got to take that negative out as I. Questions on quadratic formula? Are you ready for the next part? Now, the next part is asking about the discriminant. Find the value of the discriminant, describe the type of solutions, and find the values of the solutions. Now, this asks for all 3. The test is not going to ask for all 3. It's not going to ask you to find the value of b squared minus 4ac, tell us the number and type of solutions, and solve it. We just need the discriminant's value, what b squared minus 4ac equals, and then saying if it's 2 real solutions, 1 real solutions, or 2 complex. You do not have to actually find what the solutions are. Now, we can say 48. With these here, you have to get them equal to 0. You have to get the equation equal to 0 first. If it's already equal to 0, you're good. You don't have to do anything to it. But you have to get the equation equal to 0 first. Or more likely, if it doesn't have an equal 0, you just need everything on the same side. Because what that's going to do is help us find the values of a, b, c. A is negative 4, b is 5, c is negative 10. And we're wanting to find the value of this discriminant, b squared minus 4 times a times c. B squared minus 4 times a times c. And for us here, since a is negative 4, b is 5, and c is negative 10, we get 5 squared minus 4 times negative 4 times negative 10. All we did was plug in the values of a, b, c. 5 squared minus 4 times negative 4 times 10. 5 squared minus 4 times negative 4 times negative 10. So all I did was take that whole thing, plug it in the calculator, and it tells me its value is negative 135. That's the value of the discriminant. That's one of our answers. Now we need to compare it. We need to see, is this value of the b squared minus 4ac, is it greater than 0, equal to 0, or less than 0? Well, since it's negative, it would be less than 0. And since it's less than 0, it tells me that I have two complex solutions. And this is all the ones like this on the test are going to be asking for. It's not going to ask you to solve it. The review sheet, it did have you solve it from here. If you need more practice, especially with the quadratic formula, these are good places to do it, good examples here. But questions on how we did this one here and found the value of b squared minus 4ac, or the fact that it's two complex solutions? We go with this here. Okay. Let's look at 30. Now the first thing we need to do with this here is we do need to get it equal to 0. Now I can subtract 24x from both sides, or we could add 48 and then add 3x squared. It really doesn't matter which way we go, but we do need it equal to 0. Now I'm going to rewrite it so that it is in standard form, our ax squared plus bx plus c. Since it said negative 48 minus 3x squared, well, the 3x squared is going to be negative, so we have negative 3x squared. Our x term would go in the middle, and since we subtracted it, it would be negative 24x. And then our negative 48 would just give us minus 48. A is negative 3. B is negative 24, and C is negative 48. And then we can type it all in. If you feel very comfortable with doing this, if you want to, you could just tell me that here is 0, so I have one real solution. Because all we're doing is replacing b, a, and c with its values. Negative 24 squared minus 4 times negative 3 times negative 48. And it does tell us it is 0. I would suggest, especially if you don't feel comfortable or not sure if you type it in the calculator wrong, or you just want to be sure that you get it right, I would write it out as we did. Negative 24 in parentheses squared minus 4 times negative 3 times negative 48. Because if for whatever reason you get the calculator, you plug it in wrong, and you get something different than 0, again, it's showing me, yes, you did do it right, but it's just calculation error, calculator error is why you got a different value than what it should be. Does that make sense? Because especially for this here, if you don't put parentheses around that negative 24, it will give you a different answer. It will give you the wrong answer. Because it's not going to square the negative 24, it's just going to square 24, make it negative, give us an entirely different answer. Questions on this here? Create a perfect square trinomial and factor it. So the two big things we're looking for, I'm looking for in this here is the value of c. C is equal to b over 2 squared. We take that middle term, divide it by 2, and then square it. All the ones on the test, the number in front of x squared is going to be 1, so we won't have to worry about dividing that out. So when we look at 31, our value of b is negative 24. B is the term in front of x. So we have negative 24 over 2 squared. Now, it is not wrong to plug the whole thing in at this point, square it to find the value of c. But I normally, and what I do is I try to see if it's divisible by 2 first. 24 does divide by 2 evenly, telling us that it is negative 12. At this point here, then I put it in the calculator, parentheses negative 12, close parentheses, square. Gives us 144. Also, the value of c will always be positive. That b over 2 squared, the number we get out of b over 2 squared will always be positive. Because we're squaring it, we're multiplying it by itself. it will always be positive. The number inside the parentheses could be positive, it can be negative. But once we square it, it has to be positive. Now the other part of this said to factor it, or single set of parentheses squared. And the x will also be in there. Now the number and sign that's going to go inside there after x is the number and sign inside the parentheses before we squared it. So since it was minus 12, negative 12, we're going to say that it's x minus 12 squared. We need both. We need the 144, that value of c, and the x minus 12 squared. We need both. Questions on this here? Let's look at 32 next. For 32, our value of b is 29. Does 29 divide by 2 nicely? No. So, if it doesn't divide nicely, we're going to leave it as a fraction. Grab the calculator, say 29 over 2 squared gives us 841 over 4. So if it's reducible by 2, we want to reduce it, like the last one. Negative 24 does divide by 2 nicely, gives us negative 12. 29 does not divide by 2 nicely, so we just go to squaring it since it doesn't reduce, giving us 841 over 4. Now we do need to factor our single set of parentheses with x squared. Now the number inside the parentheses before we squared it was what? So it's going to go inside there with the x. And since it was positive, it will be plus. So it factors the x plus 29 halves squared. And that's it. Questions on this here? Questions on anything we've done so far? And if you're not sure if it divides by 2 nicely, calculator will tell us out. It'll just immediately tell us 29 over 2 is just 29 over 2. If it will reduce it, if it can reduce, the calculator will reduce it. Questions on our trinomials, finding a perfect square trinomial, making one, finding that value c. We feel good with these here. All right, we ready for the hardest part of the test here? Powers of I. Whenever we are given I to a power, I to the n, we take that value of n and divide it by 4. If we get 0.25, it's going to reduce to I. If we get 0.50 or 0.5, negative 1. 0.75 is going to be negative I. And 0.00 is going to reduce to 1. Now, most likely, if we get 0.00, it divides evenly, we won't have a decimal. Because if it divides evenly, we just divide it evenly. The calculators aren't necessarily set up to push or show 0.00. They're just going to be an even number. So really, on A through E, what do we need to do? We just need to take that exponent and divide it by 4. So we can do the first one, 27. 27 divided by 4 is 6.75. 0.75 corresponds to negative I. So it reduces to negative I. Now the graphing calculator can do it, but once it gets to a power kind of too big, it starts giving us that pixel error, that negative 3e to the negative 12, or negative 3e negative 12 plus 4, it puts it on next to one of the two. Where here, 287 divided by 4 is 71.75. Since it has the 0.75, it will be negative I. 41 divided by 4 is 10.25. So I. 2,874 divided by 4 is 0.5, which would be negative 1. 6,971 divided by 4 We have that number in front, but the part we care about is the 0.75, which will tell us that it is negative I. Now, if it was 69,072 divided by 4, we get 1,743. It's 1. Even though it doesn't give us a decimal, it's understood to be 0.00, so that would be 1. Questions on powers of I? We feel good about powers of I. We know how to find them. Yes. Divided by 4, look at the decimal. Which one does it correspond to? 0.25 is I. 0.50, 0.5 is negative 1. 0.75 is negative I. And 0.00 is 1. Evaluate each expression. A, B, C, or D. Which one do we want to look at first? C. 6 minus 4i minus negative 3i plus 2. For all these here, I would grab that graphing calculator and say parentheses 6 minus 4. Second decimal gives us I. Second decimal. Negative 3. Second decimal gives us I. Have I changed anything about this? No, I just looked at the problem, typed it into the graphing calculator exactly as it showed it, yes? Let's see what happens if we hit enter. 4 minus I. Make sure you did not put a minus in front of the 3i. You put a negative instead of a minus. Because if you did, it's going to give you an error because there's nothing in front of it to subtract. So type it in again. Type it in exactly as it looks like.
Oh, yeah, I did. It was like a... different. I don't know. Instead of parentheses.
Yep. Yeah, the wrong brace. 4 minus I. Questions on C? Well, probably a question on E, yes? Parentheses 189 I minus 361 I squared plus 71 I squared minus 38 I to the fourth. Our caret key, the button above the division sign, will let us do exponents greater than 2, our squared. Typed it in just exactly like it showed us, and it tells us it's 252 plus 189i. $252 plus 189i. So really with our addition subtraction, these problems here, really what do we have to do? We just got to type it in. We plug it into the calculator, let the calculator do it for us, we get our answer. So really A through E, all we got to do is plug it into the graphing calculator exactly as we see it. We don't have to change a thing, and it'll give us our answer, yes? Let's look at the next set. F, G, H, I, J, K. Which one of those do you want to look at? H. So H tells us that we have 2 plus 3i times 7 minus 4i times 6 minus 2i, yes? This is exactly what it looks like on the paper. So it's 182 plus 26i. So H. Really, any of the multiplications, we can just type it in exactly as we see it. So even k, 8 plus 4i squared times 16 minus 3i to the fifth, we can type it in exactly as we see it, and it'll give us an answer. Questions on our multiplication? No, we can do it by hand. We've done it by hand. We've seen how to do it by hand. At this point here, let's just type it in and let the calculator do the work for us. And that's especially true on the ACT. Simplify the following complex expression. Calculator will do it. The graphing calculator will do it. Let it do it. Let's look at division. When we divide two complex numbers, the 84 plus, the ones that y'all have will not just divide them in by using alpha y equals enter. We have to change it to dividing. We're going to take the top of the fraction, put it in parentheses, and divide it by the bottom. And we can type it in now. So we'd have parentheses, 8 minus 4i, close parentheses. Then we'll hit the division key. 3 minus I. So to get that slash is just the division key, our dividing. So we have 8 minus 4i in parentheses divided by 3 minus I, the top divided by the bottom. Math, enter, enter. Math, enter, enter. 14 fifths minus 2 fifths I. Change to fraction form is 3 keys. Math, enter, enter. Math, enter, enter. Because once we type it in, parentheses around the top divided by parentheses around the bottom, top divided by the bottom, we're going to hit math, enter, enter to convert it back to a fraction. Because every single time when we type it in, it's going to give it to us as a decimal. And for the most part, most answers, I will take it in decimal or fractional form as long as it's the exact same. But here, 3 keys to get it back to a fraction. Let's just put it in fractions. Questions on L? Even with M, even though the numerator is just the number 4, we still want to put parentheses around it. Now this one here, it might not make a big difference with parentheses around the 4 or not, but might as well put them there just to be safe. And it tells us that this one is 0.48 plus 0.64i. Math, enter, enter. And it tells us that it's 12/25 plus 16/25 I. Now the answer key does have it as a whole fraction, but the whole fraction and this broken up answer are the exact same thing. Because the way that the answer key on the review sheet has it is as 12 plus 16i over 25. They're the same thing. Either one works. Questions on division? Questions on how we divide these? We feel good with addition, subtraction, multiplication, and dividing complex numbers? Yes? All right. Q through T, find the complex conjugate and find their product. Four minus 3i, what would its complex conjugate be? It would be 4, what? 4 plus 3i, because if 4 plus, we're given a minus bi, its complex conjugate, it's a plus bi. That's half the answer. So they told us it's 4 minus 3i. Its complex conjugate is 4 plus 3i. So that it asks us to find it and find their product. So all that means for the second part is to take 4 minus 3i and multiply by 4 plus 3i. Now we can do this by hand and multiply out, or I can just grab the graphing calculator and say 4 minus 3i times 4 plus 3i. And it tells us it is 25. When we multiply the complex conjugates together, we should get a number. We should get a number without I. That is the nice thing with complex conjugates. So 18 plus 14i, complex conjugate would be 18 minus 14i. Then we would take the two of them, 18 plus 14i times 18 minus 14i, and we would multiply these two together. And it tells us it's 520. So we would need the complex conjugate of 18 minus 14i and their product of 520. What would the complex conjugate of 8i be? Negative 8i. Then we just multiply them together, 8i times negative 8i, which will be 64. And even that one, we can just type it in. Negative 19i's complex conjugate would be positive 19i. Then we just have to multiply negative 19i and 19i together. Negative 19i times 19i, giving us 361. I don't think it'll ask it because I've looked at the test. It's been a minute. But if it asks for the complex conjugate of 8, what is the complex conjugate of 8? Because again, a plus bi's complex conjugate is a minus bi. We're changing the sign in front of the I term, yes? Is there an I term here? No, so it's really, we could say that the first one is what? 8 plus 0i, and the second one is 8 minus 0i, 8 plus 0i, 8 minus 0i. It's just 8, yes? And then if we want to find their product, we're really looking at what? 8 times 8, which is, because again, complex conjugate, we're only changing the sign in front of I. Only changing the sign in front of I. And that is it. Questions on any part of the review? If you missed Friday, you need to go back and watch the first part of the review so you're ready for it. Or if you slept through Friday or slept through the day, you need to go back and rewatch the part that you missed. Because first part, most likely, especially with the Veterans Assembly tomorrow, will be Wednesday, second part Thursday.